Forget everything you think you know about chatbots. We need to shatter a dangerous illusion right now. The AI you're used to is passive, but what's replacing it is vastly more powerful and significantly more dangerous. Welcome to The Explainer. Today, we are systematically deconstructing the architecture, the true capabilities, and the severe systemic risks of autonomous AI. We're breaking down the AI agent decision engine. This is the blueprint. The engine of autonomy, the decision loop, core system architecture, the execution layer, the cybersecurity threat, and finally, guardrails and containment. We are mapping exactly how these systems operate and the critical attack surfaces they expose when we hand them the keys. We have to break this illusion immediately. These enterprise systems, they are not just answering questions anymore. They are executing operations. A script that summarizes a PDF is not an agent. A system that extracts data, generates its own documents, triggers workflows, and makes decisions based on its own logic, that is an agent. Think of a language model as a librarian. The librarian knows everything. They've read every book, but they are locked in a room. They can't check the weather, they can't send an email. They have zero agency. An agent is the captain. Same knowledge, but now with tools, memory, and the authority to act. The captain doesn't just know, the captain decides and executes. Let's lock down the definition. An AI agent is a goal-directed system. It chooses actions, it calls tools, and it operates inside a continuous decision loop until a defined objective is achieved. This is the bridge between passive text generation and real-world impact. To understand this, you have to understand the loop. This is where everything changes. The agent operates in a relentless cycle. Observe, reason, act, evaluate, observe. The system ingests inputs, data, feedback, reason. It plans its next move. Does it respond? Call a tool? Break the task down further? Act. It executes. A database query, an API call, a workflow trigger. Evaluate. It checks the result, updates its internal state, and loops again. No human intervention. This loop runs until the objective is complete. Now let's break the architecture. This system is not just a brain, it is a layered structure. It starts with memory, short-term memory, a working scratchpad, tracking the current operation. Then long-term memory, stored in vector databases, enabling deep recall across time. Without this, there is no continuity, no context, no intelligence. Above memory, we have the planning layer. This is where reasoning becomes execution. The system takes a high-level goal and translates it into a sequence of machine actions, step by step, dependency by dependency. It defines exactly what must happen next. Then comes the execution layer. This is where the system touches reality. The agent uses tools. Tools are its hands. They allow it to run code, call APIs, access systems, modify live data. This is where it moves from thinking to doing. But giving an AI system the ability to act introduces risk. This is where control becomes critical. Frameworks like the Model Context Protocol standardize how agents interact with tools. They enforce structure. They define boundaries. They ensure the system operates inside controlled interfaces, not uncontrolled access points. Now we reach the most important layer, the cybersecurity threat. Because once an agent can act, it can be exploited. Traditional defenses are not enough. This is a new attack surface. One of the most dangerous vulnerabilities is excessive agency. This happens when an agent has more access than it actually needs. And if that system is manipulated, it can execute catastrophic actions. These attacks happen at machine speed, milliseconds. It reads malicious input, it pivots behavior, It executes a payload. It corrupts its own memory. And now, its future decisions are compromised. That is memory poisoning. One bad instruction can permanently alter the system. Then there is indirect prompt injection. Hidden instructions embedded in emails, web pages, or files. The agent reads them and executes them blindly, turning your own system into an insider threat. So how do you defend against this? You don't maximize autonomy, you maximize control. Real systems require zero trust isolation, least privilege access, strict tool permissions, real-time monitoring, and most importantly, human-in-the-loop validation. Before any high-impact action is executed, this leads to the core principle. A powerful agent is not an autonomous system. It is a controlled system, a reasoning engine wrapped inside a safety harness. So now the real question becomes, what happens when an autonomous decision loop breaks containment? Think carefully about your architecture. Design for failure. Plan for worst-case scenarios. And build for control. If you found this breakdown valuable, subscribe to CyberTechHaus for deeper insights into AI systems, cybersecurity, and real-world architecture. And in the next video, we go even deeper into how these systems are actually built, step by step.